my presentation will be about hazard profiling of persistent and mobile substances using new approach methodologies. An important note here is that we are talking about hazards in a toxicological sense, so not about persistence or mobility, but we are looking at if the compounds can have any biological effects. So we are looking at those. And the new approach methodologies, I think, have been very clearly introduced already. So first, the phase 1 compounds. We talked about a lot about them, but we never showed the real complete list. So these are the compounds, 36 in total. 16 triazoles is mostly triazole fungicides, and some benzotriazoles, which are more industrial products, also used as corrosion inhibitors. And also we selected 3 transformation products that are common to many of those triazoles. Then the triazines, of course, you might recognize atrazine and melamine, which are the most famous ones. And also here we selected 3 transformation products which are common to many of the triazines. And the PFAS is mostly short-chain PFAS because those are more mobile, but also the more classical PFOS and PFOA, also to compare with the in vivo data, which is more available for those PFOA and PFOS. Of course, you cannot test the effects of compounds on the complete body with only one in vitro assay, so we needed to use a test battery. And we looked at these endpoints. So they were selected also, actually the chemical classes were selected so that at least one of the chemical classes was expected to have effects on that endpoint. Also to see if our assays are really useful to catch those compounds which are already known to interfere with them in vivo studies. Today I will only talk about endocrine disruption. Regarding each modalities, I will explain what that is in a minute. But we also look at developmental toxicity and neurodevelopmental toxicity using zebrafish embryos and nematodes. Immunotoxicity, we developed a new test in zebrafish embryos, and also liver toxicity, we are also testing it. But today I will only present the endocrine disruption. So the each endpoints, the each stands for estrogen, androgen, thyroid hormone, and steroidogenesis. For the E, we looked at agonism and antagonism towards estrogen receptors. Agonism means something like activation of the receptor. You can think of it, I will explain it also in a minute. And antagonism is something like the blocking of the receptor. Then for the androgen, we looked also at agonism, antagonism towards the androgen receptor. For the thyroid hormones, we looked also at agonism, antagonism towards the thyroid hormone receptor, but also at the displacement of thyroid hormone from transdicatin, which is a distributor protein which transports thyroid hormones from the place where they are produced in the thyroid gland to the place where they should have their effects, mostly the brain. And then finally steroidogenesis, so the production of steroid hormones, among others testosterone and estradiol, but we looked not only at those hormones but at 13 steroid hormones. So for all these assays I will quickly describe the way that we measured them, so the assay, and then also the results that we got, of course. So to start with the hormone receptors, so some cells that are sensitive to, for example, estrogens, when an estrogenic compound when it comes to contact with an estrogenic compound, the compound can enter the cell, it can bind to the estrogen receptor, then estrogen receptors can dimerize and be transported inside the nucleus of the cell, where it leads to the expression of estrogen-responsive genes. which leads to feminizing effects. And if you have too many of those, you can think of problems like precocious puberty in girls, effects on the menstrual cycle, breast cancer, or infertility in males. But to measure this, we use a reporter gene assay. So in the nucleus there is not only these estrogen responsive genes, but there's also the reporter gene. So when you have estrogenic compounds, they lead to the expression of those reporter genes, which leads to the production of luciferase. And if you add a chemical like luciferin, you can measure light intensity. So the more light you have, the more estrogenic compounds you added to your system. And then for the antagonism, so the blocking of the receptor, if you add an anti-estrogenic compound, then it will also bind to the receptor. It will also lead to the dimerization, it will enter the nucleus, but it will not lead to the expression of those genes, it will block the expression of those genes. So you will, it will lead to the opposite of feminizing effect, and also it will mean that the light intensity will become lower. That's how we measure it. And then you can think of effects like delayed puberty in girls, also effects on the menstrual cycle, and infertility in females. That's for the estrogen receptor. If you have the same type of things on the androgen receptor, agonism would lead to, for example, infertility in females, antagonism of the androgen receptor, male infertility. For thyroid hormone receptor agonism, you would think of hyperactivity or developmental neurotoxicity, and antagonism towards the thyroid hormone receptor, you might think of hypoactivity, depression, and developmental neurotoxicity. So then, some results. So all 36 chemicals were tested with these assays. For agonism on the estrogen receptor, there are only 2 compounds that showed a little bit of effect. Every time we also use a reference compound. So estradiol is a very potent agonist. So you can see that our compounds are really much less potent than estradiol. And it's 2 of the triazole fungicides that show the effect, triadimenol and cycloconazole. For antagonism, it becomes a little bit more interesting because there are more compounds that show the effects. So it's also mostly the triazole fungicides that lead to antagonism towards the ER, but also one of the triazines, amitrin, which is also a herbicide, a little bit similar to triazine. Then AR antagonism, you see that there's a lot of overlap between the compounds that we saw on the ER and the AR. So it's mostly the fungicides that have effects here, and also the ethylatrazine. Here we only see 4 compounds which had effects. Those are amitrin, difenoconazole, triadimenol, and propiconazole, which is also a big overlap with the other assay. Then to the next one, binding to TTR. So I already explained what TTR does. So we test it with the FITS-T4 TTR binding assay. So it uses molecule made of T4 and FITC. FITC becomes more fluorescent when it is when the T4 is bound to TTR. So if you see a lower signal, that means that something else is binding to TTR and therefore preventing FITS-T4 from binding. And so that way you can quantify how much of the FITS-T4 is bound to TTR. So here we see that the PFAS are very potent compounds. That was already known, but it's a very big difference from the other assay. And also some of the triazoles also can a little bit bind to TTR. Then steroidogenesis. those are all hormones made originally from cholesterol. So you go from cholesterol to pregnenolone, and then that is transformed further until you get to the hormones like testosterone, 17-beta estrogen. And the little arrows you see on top of them, you see the CYP enzymes that are important in the transformations. So, and this is also a cell-based assay, so the H295R assay. And triazole fungicides are known to inhibit the CYP enzymes. So, and you see there are many of them in this pathway. So, also that you can see, these are some examples of the hormones that you see effects on. So you see obviously that if you're exposed to the triazoles, you see lower concentrations of those hormones. Then an interesting thing is that the 3-beta HSD is a completely different enzyme. So that one is still working when you're exposed to the triazoles. So then you expect the progesterone, 17-alpha hydroxyprogesterone, to be accumulated. So you see increases in those. And that you also see in these results. So that's interesting. Then we also have the triazines. Atrazine is an inducer of cyclic AMP, and you see that mostly for the CYP19, so the aromatase. You see very big increases in the estrogens that they produce. So here you see atrazine, diethylatrazine, and ametrine. If you're exposed to those compounds, you see really big increases in the estrogens. And also in the same graphs, you see that the triazoles lead to a decrease, and that is also the same mechanism that I showed before with the CYP inhibition. Yes, so those other assays, I will not go into that now. Just to conclude, here I put all the data in one figure. So on the x-axis you see all the assays that we did. The H295R is the stereogenesis. And you see that for the PFAS, they don't really do anything on other assays than the TTR binding assay. The white color means that there was no effect. Light blue color means that there was an effect, but not so potent. And the dark blue is really the more potent effects. So PFAS are mostly on TTR. Then from the triazines is mostly ametrine, which shows a lot of effects on many different assays. And then for the triazoles, it's really a lot of effects on many of our readouts. I also have a poster, so if you're interested, you can also look at the website. So thanks to Timo, Mayuri, and Peter from Vrije Universiteit Amsterdam, Sylvia, Jenny, and Abhishek from Fraunhofer ITEM, and also Todd. Thank you.
ZeroPM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under grant agreement number 101036756.